What happens in FA, this is the FA gene, there is a mutation which is an expansion, so is an elongation in this site, which is not one of the sites where we actually explain how to make up the protein, but is a little site that is basically between the first one and the second green block. So to try and explain it a little bit better, I think I could make this parallelism about the fact that these green blocks, which are called exons, can be compared to basically what's written on every single page of the booklet. So I just put the little green blocks here to just show that every single block can be seen as basically one page of the booklet on how to build up a protein. And what's between them is still DNA, and it's basically what can be seen as the thread that keeps the booklet together. So in a normal condition where there's no mutation, what happens is that the booklet is well built and gets sent out to the workers, and the workers are able to read it and to produce the protein. In the case of ataxia, there is a mutation, as we said, in between the two green boxes. So what happens is that, in theory, we should be able to have all the information to build up the protein properly. But the problem is with the thread, because of this mutation, it's really hard to kind of build up the booklet properly. So the single pages are kind of not well related one to the other. And what happens is that the workers end up not being able to read the booklet and not be able to produce the protein as they should. And this is just another little cartoon to explain what happens. So in a normal condition, there is an enzyme that comes and reads the DNA and goes through the pages of the booklet, and that's just in a normal condition. They go through the booklet and they just produce that, which is the actual protein. In FA, what happens is that this enzyme kind of gets stuck here and is not able to kind of continue. And that is a problem. That doesn't happen every time, but most of the time. So the amount of protein that is produced in FA is a lot less than what's
so sometimes it does work.
Sometimes it sometimes works, but not always. Okay. So I represented it as a little fraction of what it should be. And what happens in the end, of course, in ataxia is that the mitochondria receive less or none of the protein that is needed. So what does that lead to? So of course, one of the first things that happens is that we have less production of energy, because as we said, the mitochondria are the main sources of energy. They're factories to produce energy. They kind of get impaired because they don't receive enough proteins to do that, to keep up with energy production. There is an impaired iron metabolism, so the way we metabolize iron gets affected. And there's also more oxidative stress. And to explain what oxidative stress is, I just put this photo of an apple. So this side, of course, is not oxidized, but this side is. And oxidative stress can have a lot of consequences, and we think that it can finally lead to cell death if it is past a certain threshold. So how do we usually fight in our body? How do we usually fight oxidative stress, which always happens to a certain extent? We usually produce a molecule which is called glutathione, or other molecules which are similar in the kind of effect they have, to kind of block this oxidative stress. But the problem is that a lot of these molecules, including glutathione and other molecules that are similar to it, are impaired in FA. So FA people have some difficulties in block this oxidative stress. So what does the drug do? It works on this enhancer in the nuclei to basically enhance the production of glutathione, so to enhance the production of the booklet on how to produce glutathione and other antioxidant molecules. So as we said, to kind of help the workers to produce more of these molecules to fight against oxidative stress.